afternoon, everyone. Welcome. I would like to welcome you to warmly to the session 5B, which will focus on natural language processing and machine learning. So, before I introduce Dr. Tilina, who is the chair of this session, session coordinator will post a link to a Google form in the chat. So you can use that link to provide some feedback for this ICTer conference this year, so that we can use those feedback and take that positive and negative things into the next year and probably and hopefully improve our conference. So with that, I would like to invite Dr. Tilna Hallolua with a brief introduction about himself. He's a senior lecturer in the University of Colombo School of Computing. He has a PhD from the Science and Engineering faculty at the University of Queensland University of Technology, Brisbane, and he was also the winner of Executive Dean's Commendation for Outstanding Doctoral Thesis Award for the year 2019. He is also one of the founding members of ACM SIGCHI Colombo chapter and currently represents Sri Lanka at the International Federation for Information Processing Technical Committee on Human-Computer Interaction. Within the fields of computer interaction and computer-supported cooperative work, his research focus is on designing for underserved communities. So I would like to warmly welcome Dr. Halolua to continue this session.
Right. Welcome all of you for probably the final session of the conference. We are having very enlightening presentations upcoming, so be with us. So the first presenter for today is M.H.M. Hisa. His paper title is Cross-Language Information Retrieval for Accessing the English Web in Sri Lanka. Hisan is a student of the University of Colombo School of Computing with a Bachelor of Science honors degree in computer science. He is currently employed as a software engineer at WSO2. His research interests are in the fields of NLP, natural language processing, and his final year research was on improving the quality of results obtained when browsing the web in Sinhala language. So, Hisan, over to you.
Hello everyone. Every time when we want to find out about something, what do? We open up a browser, go to a search engine and browse the web for information. And more often, we are able to find the information that we need. Anyone information in this way? Let's consider an example. A student wants to know how to find the factors of a number. He browses the web and he is able to find the relevant information. Let's say there is another student who has the same question, but this student is not good in English. So the student goes to a search engine and types the same question in Sinhala, which is the native language of the student. But he is not able to find the relevant information. Search engines use the concept of information retrieval, where a given query is matched with the documents of the same language. Since English is a very popular language, there is a massive content in English embedded in the web. So for a given query in English, there is more likely to be several documents which provide relevant information. If we consider the Sinhala content embedded in the web, it is very much low. So more often, there will be few or no documents at all relevant to a given Sinhala query. In this example, both the students had the same question, but only one of them was able to find the relevant information. We could also see that the information required is available, but it is inaccessible to the question given in Sinhala due to the language mismatch of the query and the documents. This is where cross-language information retrieval, or CLIR, comes into play, where the query given in one language is matched with documents of another language. So I welcome you all to the research paper presentation of cross-language information retrieval for accessing the English web in Sinhala. EFEPI is an index which is used to rank countries by the level of English language skills. As you can see here, Sri Lanka is in the 78th position, which belongs to the very low proficiency band. According to the Census of Population and Housing data, the English literacy rate of Sri Lanka is low. So there are many people who are not able to search the web for knowledge. This study will help a lot of Sri Lankans who will be able to search the web for information using their mother tongue. Two research questions were considered in this study. The first one was how to convert the Sinhala search query into the equivalent query in English. And the second one was how to evaluate and re-rank the results returned in order to present the user with the most relevant documents. Next, let's look at the related work. There have been 3 translation strategies used when performing CLIR. The query translation approach translates the query to the language of the document. The document translation approach translates the document to the language of the query, and in the interlingual technique, the query and documents are translated to an intermediate language. Among these approaches, the query translation approach is popular due to inexpensive operations and low overhead. Dictionary-based approach using statistical machine translation and corpus-based approach are some of the query translation techniques. Word embedding is a concept which transforms a given word to a vector of real numbers. When a set of given words are visualized in a two-dimensional space, it can be seen that words with similar meanings are grouped together and are close to each other. Word2Vec, glove, and fasttext are some algorithms that have been proposed to create word embeddings. If we consider word embedding models which have been used for cross-language tasks, the most popular method is the mapping-based method, which can be further divided as regression, orthogonal, canonical, and margin methods. A very common regression method approach is the linear transformation. In this method, by projecting a word in one embedding space to another embedding space, the relevant translation can be found. This method employs the nearest neighbor concept to retrieve translations which is based on cosine similarity. It has been reported that there are certain points known as hubs which are returned as translations for many words when the nearest neighbor is considered. This is known as the hubness problem. The globally corrected neighbor retrieval method has been proposed to mitigate the hubness problem. This method employs a mechanism to re-rank the nearest neighbors by downplaying the importance of elements that are occurring as hubs. The orthogonal method has shown improvement over the basic regression method, and it suggests that the projection should be orthogonal. This transformation can be computed using singular value decomposition. This method employs a mechanism called the inverted softmax to reduce the hubness. There have been several work which uses word embeddings to perform CLIR for different language pairs. So as we saw, word embedding is a great tool to work with text data, and it has shown to work well for CLIR tasks. Hence, in this study, we will be using a word embedding based approach to perform CLIR for the Sinhala English language pair. Moving on to the research design, let's take a look at the high-level architecture. The user submits the query in Sinhala language. The equivalent English query is obtained using the translation model. The results are obtained using the Google Search API. The results are translated back to Sinhala using Google Translate. And based on the performance of the re-ranking models, the results will be re-ranked or displayed in the same order to the user. Let's look at what's involved in the process. Step 1 will be obtaining word embeddings for the source and target languages. Here, the source language will be Sinhala and the target language will be English. A publicly available Sinhala corpus was used to create the Sinhala word embedding model, and this corpus consists of more than 100 million words. The corpus was subjected to preprocessing and transformed into a two-dimensional list where each element is a word. This list was fed into the GenSim library, which provides functionality to create word embeddings using the fasttext algorithm. Word embeddings with 300 dimensions was created using the continuous bag of words architecture. Fasttext uses parts of words and characters when learning word embeddings instead of using whole words. So it has the ability to generalize to unknown words. Hence, it was decided to use fasttext to create the Sinhala word embedding model. The pre-trained word vectors available for English language was used as English word embedding model. This model has also been trained using the continuous bag of words architecture, providing 300 dimension vectors. At this point, we have obtained the word embeddings for the two languages. Next, we need to employ a method to obtain the equivalent English query for a given Sinhala query. In order to do this, a translation model was created. The translation model consisted of two components, namely the projection component and the retrieval component. The projection component was to map the source embeddings to the target embedding space. Two different approaches were taken to create the projection component: the linear transformation method and the orthogonal method. Apart from the source and target language embeddings, to create the projection component using either of these methods, a dictionary is required. To generate the dictionary, the most frequent 6,500 words of the 100 million word Sinhala corpus was obtained. These words were translated to English using Google Translate. Then it was split with 5,000 pairs as the training dictionary and 1,500 pairs as the testing dictionary. Then the projection component using both the methods were created using the source and target embeddings along with the source target dictionary. This projection component is then used to map a source word embedding to the target word embedding space. But this will not result in a translation. It will be just an embedding in the target space. The embeddings of the target language will also be in this space around the mapped embedding. In order to obtain a translation, this projected embedding should be linked to an embedding in the target space, since they are the embeddings that represent words in the target language. This is the task of the retrieval component of the translation module. The retrieval component returns a translated word corresponding to the source word, which would be the final output of the translation module. Two types of methods were Two types of methods for each of the projection components were incorporated as the retrieval component to retrieve the correct English translation. For the linear transformation method, the nearest neighbor and the globally corrected neighbor methods were incorporated. And for the orthogonal method, the nearest neighbor and the inverted softmax methods were incorporated. Hence, four different models were considered as the translation models. The testing dictionary of 1,500 words was used to evaluate the four translation models. During a translation, since the best possible results are needed, the precision at one measure was considered. The P1 measure was calculated by finding the percentage of Sinhala words in the testing dictionary, which gave the correct English word. The LTNN model, which has the linear transformation projection component and the nearest neighbor retrieval as the retrieval component, obtained the highest P1 measure of 35%. Therefore, the LTNN model was used for subsequent processes of re-ranking and user evaluation. The English equivalent words obtained using the LTNN model for several Sinhala words are shown here. The query translation process takes place by splitting the source query into a list of words where each word is fed into the translation model and the target word is obtained. Then the set of target words are combined to obtain the target query. The English equivalent queries obtained using the LTNN model for several Sinhala queries are shown here. At this point, we have finalized on a translation model. The next step was to retrieve the documents corresponding to the query. The Google Search API was used to retrieve the documents using the equivalent English query obtained, and this returns a JSON object. Step 4 was to re-rank the documents with respect to the original query given in Sinhala. In order to do this, the following steps had to be performed. The JSON object does not contain the content of the web pages. As a result, the web content had to be extracted in the URL of the web pages. This extracted content was then translated into Sinhala using Google Translate. Then the following re-ranking models were applied to the translated documents. In the basic re-rank model, we calculated the number of times the terms in a search query appears in the document and normalized them by dividing each value by the length of the document. Then the documents are ordered in the descending order. In the LSI-based re-rank model, we employ the latent semantic indexing to re-rank the documents, which uses singular value composition to identify patterns. Now let's look at the evaluation process. Most of the work that addresses the CLIR task has a set of labeled documents. They use the mean average position as the evaluation metric. It retrieves documents from the web, so there are no labeled documents. Therefore, user evaluation was conducted to find the performance of the different models. A diverse set of Sinhala queries were required to perform the user evaluation. Hence, a Google form was created and distributed among the university students to collect the queries. The analysis was carried out by calculating a score for each model to determine the performance of the models using the following two formulas. According to this, the model having lower score would be the best performing model. Two evaluations were carried out where the focus of evaluation 1 was to determine the best ranking model from the basic model and the LSI-based model. 20 Sinhala queries were translated to English using Google Translate, and for each query, 50 documents were retrieved using the Google Search API. These are the documents obtained without any re-ranking process. The first result returned from the Google Search API was extracted to be used for the evaluation process. Next, these documents were separately re-ranked using both the re-ranking models, and the top ranked documents were extracted. So for each query, 3 documents were extracted for the evaluation process. The 3 documents were produced by 3 different models as shown. All these models use the Google Translate as the translation component. The model 1 did not have any re-ranking mechanism. Model 2 used the basic re-rank model, and model 3 used the LSI-based re-rank model. 4 separate Google forms were created, each having 5 queries to evaluate. Each query had 3 documents corresponding to the 3 models. The evaluator's task was to read the 3 documents and rank them according to the opinion of the evaluator. Each query was ranked by 10 evaluators. These are the model scores for each form as well as the final model scores. It can be seen that model 1 has obtained the lowest score in each of the 4 forms and hence has the lowest final score. This shows that model 1 performs in a consistent way and is the best model compared to the other 2 models. Hence, these results show that the queries translated using Google Translate performs well when no re-ranking is applied. From the remaining 2 models which were subjected to re-ranking, model 3 has shown to perform well since it has the second lowest rank. And it is consistent across the 4 forms. Hence, the LSI-based re-ranking model can be determined as performing well than the basic re-rank model. The focus of evaluation 2 was to determine the best performing overall model, which once identified could be used to implement the final system. This evaluation followed a similar procedure as evaluation 1, but considers 4 models, and the first result of these 4 models was used for the evaluation. Since this study tries to provide a solution to the current Google Sinhala search, it was used as a model in this evaluation to compare the performance of other models against Google search. Model 2 was Google Translate model without re-ranking. A model with LTNN as the translation model without re-ranking was also considered in this evaluation. The LSI-based re-ranking model was combined with the LTNN model to determine the performance of the LTNN model with re-ranking. Hence, 4 models were considered in this evaluation. 2 separate Google forms were created, each having 5 queries to evaluate. Each query had 4 documents corresponding to the 4 models. Similar to the previous evaluation, each query was ranked by 10 evaluators. These are the model scores for each form as well as the final model scores. It can be seen that Model 3 has obtained the lowest score in each of the 4 forms and hence has the lowest final score. This shows that Model 3 performs in a consistent way and it is the best model compared to the other 3 models. It can also be seen that Model 3 has performed well than Model 4, which can conclude that LTNN performs well when no re-ranking is applied. Moving on to the conclusion, the aim of this research was to provide a way for people who are not fluent in English to be able to search the web in Sinhala. This involves finding the best equivalent English query for a given Sinhala query. Hence, this study included checking the performance of various word embedding-based translation models in order to find the best performing model. 4 different translation models were used, and the translation model developed using the linear transformation model built a standard nearest neighbor retrieval method performed the best when evaluated on a test dictionary of 1,500 word class. This obtained a P1 measure of 35%. Hence, this model could be used to translate word by word to convert a Sinhala query to an approximately equivalent English query, which could provide the correct translation of the main keywords in the Sinhala query, which is the vital component in retrieving relevant documents. 2 re-ranking mechanisms and the results of evaluation 1 showed documents obtained after re-ranking them using an LSI-based model gave good results compared to the basic model. But the documents obtained from the queries translated using Google Translate without applying re-ranking were more relevant. Evaluation 2 also shows that the LTNN translation model performs well without re-ranking. Hence, it can be concluded that the effect of re-ranking the translated documents does not show a positive impact, and the final system should present the documents to the user in the order they are obtained using the Google Search API. The Google Search API provides only 100 results for a particular query and allows up to 100 queries per day. So in the evaluation process, only 50 documents were considered per query due to this query limit, but considering more results might have an impact on the re-ranking process. Also, the results obtained from Google Search API do not include the content of the documents. It also has an impact when translating the document back to Sinhala, since the document to be translated would not contain the content alone, but some other unnecessary text as well, which would have an effect on the re-ranking process too. Looking at the future work, the translation models created in this study performs a word-by-word translation when given a query. This procedure can be extended to handle page translations to obtain more accurate results. Also, there can be words whose translations might not be the first result given by the translation model, but it may be the second or third result as shown in the example. In such cases, an English language model could be trained and used to identify the correct translation. This study looked at few projection, retrieval, and re-ranking mechanisms. Other mechanisms could also be tried out. This concludes the presentation. Thank you all for listening. Feel free to ask any questions you have. Hello, everyone.
Thank you, Isan, for that presentation.
We use a browser to a search engine and web.
Just stop sharing, please. Right. Thank you for that presentation. Now the audience can ask questions. If there's no questions, we can move to the next presenter. Are there any questions? Right. So thank you, Isan, for that presentation. We'll be moving to the next presenter. Okay. The next presenter is Ms. Nimali Vasana Hettiarachchi. The paper is titled "Detecting Hate Speech in Social Media Articles in Romanized Sinhala." She has completed her undergraduate studies at the UCSC, obtaining a BSc in Computer Science, and she has a master's qualification in Computer Science from the UCSC as well. Nimali, the floor is yours.
Good evening, everybody. I'm Nimali Vasana. I'm doing the research related to natural language processing. It is detecting hate speech in social media articles of Romanized Sinhala. My supervisor is Dr. Ruanveera Singha and co-supervisor is Dr. Randir Pushpanand. Through the introduction of my presentation, I will give an understanding of the background of the research project, and finally goals and objectives scope will be presented here. Background of the research. In the research can be divided in the Romanized Sinhala, hate speech and social media. Can be divided in the three main steps. Firstly, I introduce what's the Romanized Sinhala. The meaning of Romanized Sinhala, we can write the Sinhala language by using English script. As an example of, you can see the words of Amma, the word can be written in English characters. Such as AMMA. We call this writing style as the Romanized Sinhala. What's the social media? Most of Sri Lankan people and all other have a basic idea about what is social media. Social media can be determined by the interaction and communications of the content created by users. Social media is a virtual life for the and place where people can express their feelings and opinions and benefits. Also, then what's the hate speech? According to the most national and international legislation, hate speech is referred as expressions that prompt harm, discriminations, hostility, and violence based on some identified social groups. Hate speech can be include many forms of expression such as images, videos, songs, as well as comment. In this research, I mainly focus only the written comments. So here I move to the research problem statement here now. Mainly we are focusing on the how to detect the hate speech in Romanized Sinhala language automatically. Also, in this research, mainly find the which approaches suit for this, such as lexical bridge approaches or machine learning approaches or hybrid approaches. Hybrid approaches means combinations of lexical bridge approach and machine learning approaches. In this research, main goal is overcome the problem of identifications of hate speech in social media in Romanized Sinhala. Here, manually annotate the response as hate speech or not, categorize the hate speech being published in the social media, identify the different type of hate speech detection methods, emulating the main reasons for the failure of present technology to detect the hate speech in Sri Lankan context, designing, implementing, and evaluating effective technique for detecting hate speech in Sri Lankan context. In this research, I mainly focus on the text analysis problem limited to the Romanized Sinhala language, social media comment use as a data set. Automatic hate speech detection does not have a long history, but there has been a huge interest in the last 10 years. Since most scenarios comment posed as the hate speech, so this is as the text analysis problem. So the three main approaches can be identified for the text analysis as lexical-based approaches, machine learning approaches, and hybrid approaches. Lexical-based approaches rest on the idea that most important part of the text classification task, being able to understand in text phrases. In here, machine is fed with pattern of language, grammar, manually created rules describing certain type of text, or as domain-based knowledge describing certain type of text. The machine learning approaches. Both supervised and unsupervised learning algorithms can be used here. But currently, problem of online hate speech detection is the supervised learning problem, so also as the text analysis. The hybrid approaches, we can use both machine learning approaches and text classification approaches for this detection method. Firstly, the lexical-based approaches is used for the data filtered, and then those filtered data is fed into the machine learning model. Lexical resources are used to extract features from text data, and those features are fed into the machine learning model. Through this part, I will give the understanding of the design and methodology, which I use here, such as supervised learning model is used here, dataset, how to create the dataset, how to reprocess the dataset, feed extraction method, classification method, and evaluation part will be discussed here. Here you can see the design of the supervised learning model here. Entire process experiment can be divided into 5 main steps as a data collection and annotation, data pre-processing, feature extraction, classification and evaluation. Also, in this research implementation to feature extraction method implementation, I will use the Python Scalar library, also Python 3 used for other implementation activities. The dataset, the collected dataset has a different articles consist comment written by social media and Facebook in the Sri Lankan contents. Here I collect the both category because of the most Romanized Sinhala comment includes Sinhala words. And if there has any include Sinhala words, I convert those Sinhala words into the Romanized Sinhala by using Unity Code Python library. Then in my dataset, each data in the dataset will determine if there is a hate history or not. There are only two categories now. If that is comment had hate speech, that's labeled as yes. If not has any hate speech, they are labeled as a no. Among my data set, among them, it has a 1,400 data have been manually annotated as a hate speech and 1,100 comment manually annotated as a hate speech. Also, in the pre-processing, to reduce the noise, all text should be cleaned before they are applied for the classifiers. In the pre-processing part, I use the implementation as the beautiful soft functions. It is one of the best pre-processing library which can use for these tasks. Using this beautiful soft, we can remove the HTML tags, remove analphabetic characters, convert all text into the romanizing, remove special characters, organizations, stop words, stemming and basic pre-processing is typically used in this research by as the pre-processing part. To the feature extraction, we have explored the n-gram feature types in our experiment. In the feature extraction, create a bag of words representing the data set in here. Utilize the word n-grams, implement for the unigram, bigram, and trigram, and predict and evaluate using the tokenized data. By using the Scalar toolkit Python, we implement the feature extraction activities. The feature extraction codes basically rely on the functions on Scalar toolkits. The classification model, here we use the supervised learning techniques for the detecting hate speech in Romanized Sinhala. Used for the 4 different classification frameworks were tested for our classifications such as support vector machine, naive classifier, random forest classifier, and logit stratification will be used here. For my experiment, use dataset consists around 2,500 comments. Among them, divide the 2,000 comments as the training dataset and 500 comments as the testing dataset. Apply the feature extraction and different classification method with the different n-gram values, such as unigram, bigram, trigrams. I also use the different MinDF values, such as MinDF value 1, 2, and 3. Finally, select the best n-gram values as the bigrams and best MinDF value as the 3. Also, some parameter tuning used for get the best accuracy values for my resulting set. And finally, you can see the result of counter-classifier feature extraction method by using 4 classification method with bigram and MinDF value 3. By using this result, you can see the minimal naive classifiers accuracy, precision, recalls, and F1 score values is higher than other classification models. According to this result, naive classifier has best perform with the best accuracy and other precision values. Also, here I show the train and test accuracy values for the counter tracer with a different flow classification method with bigram and MinDF value 3. You can see the difference between train and test accuracy values with for different classification method. You can see minimal naive classifier perform well with the very less difference between other classification model. That means the model generalized well from our training data set to testing data set. Also, same as this is the result of the TF-IDF vectorizer. As you can see in the same as for classification method, you can see here naive classifier perform well by comparing other 4 classification methods. The same Here I compare the difference between test accuracy and train accuracy values. You can see in the difference between train accuracy and test accuracy, very less values in the now-based classifier. So that means our model generalized were from our training dataset to testing dataset. And so finally, here I compare the two feature extraction method, TF IDF factorizer with counter factorizer. In the above result set, I will explain the now-based classifier perform well with bigram and MinDF value 3. Here I compare the different feature extraction method, TFDF, IDF factorizer, and counter factorizer. You can see the accuracy and precision records values from TF-IDF factorizer is higher than counter factorizer. So we can say my now-based classifier perform best with TF-IDF factorizer with bigram and MinDF value 3. Also, by expanding the by expanding the data set, we can evaluate the accuracy values. Here, check and evaluate the different n-gram values with different MinDF values with different feature extraction method with follow classification method. Here, I explain why I am selecting the now-based classifier perform well, why I am selecting the bigram values from different n-gram values, and why I am selecting the MinDF value as a 3. Also, why I am selecting the 2,500 comments as my dataset. Here, you can see classifier model perform better when the size of dataset gets increased. You can see all classification methods are perform well when increasing the dataset. As an example, the second table, the 20,000 dataset F1 score and accuracy values higher than thousands and 1,000 and 315 dataset. So I use the 2,000 and 1,500 dataset for my classifications. In here, in this result table, you can see when by using the counter factorizer feature extraction method with a linear support vector machine with different unigram values and different MinDF values. By using this result, you can see the MinDF value 3 is the perform best other values. Also, when you are using the logistic regression as same as you can see MinDF value 3 with bigram values perform best. As the same as when you are using the random forest classifier, you can see MinDF value 3 and bigram values perform best. So here as the same as the now-based classifier, the MinDF value 3 is perform well. So when I'm using the bigram values, I MinDF value 3 for my evaluations. In the same as when we are getting the TF-IDF factorizer, when I'm getting the result from different bigram values and different MinDF values, you can see MinDF value 3 is a perform best with other values. At the same as you can see when you are using the linear support machine, MinDF value 3 is a perform best, as well as random forest classifier MinDF value 3 and 3 is a perform best. So after that, finally, you can see the now-based classifier perform best with MinDF value and bigram values. So after the, finally, I use my class resulting set and evaluation use MinDF value 3 and bigram values. Also, you can see the minimal now-based classifier perform best with other classification model. Finally, in my research, I will I will print my most hate word set and least hate word set from my train model. You can see here have a lot of hate word set. If you have any idea about singular hate words, you can see here that is a very most hate word set filtered by my train data set. Also, you can see least hate word set here as such as Nisa, Minisu, Honda Sir, Police, Rattaram, Puta, like this. That's not hate word set. So my train model is returned least hate word set correctly. So as a conclusion, online hate speech can be identified automatically up to some context. Supervised learning method perform better than unsupervised learning method. Also, now-based classifier with TF-IDF feature extraction method perform best with cross-validations here now. Classifier models perform better with size of the dataset gets increased. As the future was, I had modified the SoundX algorithm for the Romanized Sinhala, but it is not successfully method. That is because SoundX algorithm for Romanized Sinhala has to be created. Really, I created some modified SoundX algorithm for Sinhala, but its running time is very large. I spend more than 20 minutes to read my data set. So I'll ignore that SoundX algorithm. By future, I like to change the SoundX algorithm for Romanized Sinhala. Also, try to use the semi-supervised learning technique for the data analysis and try to process the data set by using SoundX algorithms. Thank you. Any questions?
Thank you, Nimali, for that enlightening and entertaining sort of a presentation. And I'm sure the potential or the possibilities of this kind of research, the applications are endless. So, for the audience, now the floor is yours to ask questions. Until the audience prepared, I'll ask a question. I mean, when you are annotating this hate kind of words, did you consider the context of use or simply the word itself? I mean, you can basically say a hate sort of a word without meaning hate.
Only input those data set by getting the meaning of the words and meaning of the sentences.
Okay, so you took the meaning of the sentence to consideration as well. Okay.
Sentence and yeah.
What about things like sarcasm? Can your model understand things like sarcasm? Can your system can understand those? Model can understand those. I mean, if you haven't checked, that's fine.
No, I haven't checked it.
No worries. Audience, if you don't have more questions, let's move to the next presenter. Thank you, Nimali, for presenting. Right, so next presenter, unfortunately, we don't have a presenter. Due to an unavoidable circumstance, she won't be able to present today. But we have a recorded presentation. Let's have a look. The paper is titled Combinatorial Impact of Technical Indicators on Price Predictions in Colombo Stock Market. She's WPA Lavanya, who has received her master's and the undergraduate BSc from UCSC. Let's play her video.
Lavanya, my research topic is combinatorial effect of technical indicators price prediction in Colombo stock market. Today my agenda is introduction, analysis of stock market, research questions, research designing, data selection, methodology, and final research conclusion. Moving to introduction, discuss the stock market get their investment decisions by using the previous table with stock price variations through the stockbrokers' best efforts of companies' name sites. Stockbrokers have massive experience at counting its way through directly connected stock trading every day. But none of them were based on analyzing past stock data, and the prediction was often found to be inaccurate. So investors became more active to guide their transmission. Most researchers predict stock price by using individual technical indicators, but identify the best method to predict stock price typically. Because moving average don't consider changes that may affect the security of MACD is always different from person to person. On balance value do not generate absolute value. other oscillator manipulates a lot of the signal. Moving to analysis stock market, there are three types of analysis, and they are fundamental analysis, technological analysis, and the technical analysis. In fundamental analysis, there is no scope for finding the past trend, also the variations price trend. Technological analysis involves with artificial neural network and genetic algorithms. Technical analysis is mainly focused on internal market data. Technicians believe that the past trend will be repeated again, and the current momentum can be used to study the future trading by using the technical analysis. It is used to identify the patterns of stock price with short-term and long-term data to predict the stock price. There are three types of techniques, and they are market types, charts, technical indicators. For this lecture, I use technical indicators. Technical indicators are divided into two main categories, and they are leading indicators and lagging indicators. Leading indicators are considered to point towards the future event and can be used shorter periods than the lagging indicator calculation. Lagging indicators are confirming trend progress. Indicators from leading and lagging indicators are below one of the following types. Trend indicators used to measure the strength of a trend, some form of price averaging to establish a baseline. Momentum indicators used to calculate by comparing the current closing price to the previous closing price. Volatility indicators are used to measure the rate of price movement. Volume indicators are used to measure the strength of a trend or confirming a trend direction based on some form of averaging or volume. In this diagram, you can see how indicators are mapped with categories and types. My research question is how to identify which are the best combination of technical indicators to predict stock price. Moving to my research, investigate methodologies that are used in stock market and select the technical analysis, then select the data set. After go through the individual technical indicators set and identify how to combine technical indicators. My next step was both those identified combination data set and finally identify which are the best combination of technical indicators to predict stock price. I have selected basic data as 136 among the M don't holding data set from 2nd January 29th March 2018. Moving on to my methodology, first I implement fundamental analysis because there is no past price, also the variations in price. Then import technological analysis. Please indicate 50 and 7 as negative levels of a between the rating. Also, reversal. STD is used to measure the expected risk and determine the significance of certain price movement terms. Bollinger Band is used to measure the highness or lowness of the price relative to the previous data. Upper band is 2 standard deviation above the moving average. Lower band is 2 standard deviation below the moving average. Bollinger Bandwidth measure it between upper band and lower band relative. Bollinger Band narrows when upper band increase and lower band decrease. Bollinger Band widens when upper band decrease, lower band increase. EMF is based on changing accumulator distribution. For more details of each technical indicators are given in the research paper. To analyze the effective of the combination of technical indicators selected above, they are divided into two as shown in the diagram. Group A is considered technical indicators which are smooth closing price of trend, and Group B is consists of technical indicators which deviate around the closing price trend. Then the following experiments are conducted to identify the best combination of technical indicators. Experiment 1 was how to combine group A technical indicators and identify which combination best. AI represents the I technical indicators from group A and NAI is represents the number of questions of AI where I equal 1 to 7. I equal 1 is the first selection. Number of questions of the first selection is 7. The next selection is I equal 1 to 7. There, select I different technical indicators from group A and merge them by taking their average. Or the previous selection is merged another different technical indicator. Number of questions of A to 21, A3 and A4 is 35, A5 21, A6 7, and A7 is 1. They will use this algorithm for each group I equal 1 to 7 in A all, obtain the results by merging all the technical indicators of each combinations in AI and plot the each results on a graph. Identify the best combination in AI that demonstrate the smallest difference between the closing price and the combinations. After finish the for loop, plot again all these 7 best combinations identified from each AIs and identify the ultimate best combination in group A that demonstrates the smallest difference between the actual closing price and the combinations of the graph. When I equal 1, obtain the smallest difference between the closing price and the combination as the best combination as EMA. When I equal 2, best combination is average of SMA and EMA. Go through the algorithm and obtain these results. Go through the algorithm and obtain these results. Now plot again all these 7 best combinations identified from each AIs and obtain the best combination as average of SMA, lower band, upper band, lower band, average is EMA in X1. Rules how to combine group technical indicators. Like in the previous selection, can select technical indicators here also. The difference is I is equal to 1 to 4. Experiment 3 was how to combine group A technical indicators with group B technical indicators and identify which is the best. They use this algorithm. For each group AI, I equal 1 to 7 in A all as the outer follow. For each group BJ, J equal 1 to 4 in B all as the inner follow. Obtain the results and merge the each combination in AI with each combination with EJ and by ignoring the impossible combinations. Plot each the result on a graph and identify the best combination between AI and BJ that demonstrate the smallest difference between the actual closing price and the combination. Once finished the inner follow, plot all these 4 best combinations identified from each BJ and identify the best combinations with AI and B all that demonstrate the smallest difference between the actual closing price and the combinations of the graph. Once finished the outer follow, plot again all these 7 best combinations identified between A all and B all and identify the ultimate best combinations between them that demonstrate the smallest difference between the actual closing price and combinations from the technical indicators. For example, for this algorithm, when I equal 1 and J equal I equal 7 and J equal 7, the best combination is A7 with STD. I equal 7 and J equal 2, the best combination is A7 with STD and CMF. I equal 7 and J equal 3, the best combination is A7 with the STD, CMF and BBW. This is the best solution for I equal 7 and J equal 4. This is the best solution for I equal 7 and J equal 1 to 4. This is the best solution for the I equal 1 to 7 and J equal 1 to 4, which means the best solution of the experiment 3. Experiment 4 was identify which is the best combination of the obtained results from experiment 1 and experiment 3. Plotted the best combination obtained from experiment 1 and experiment 3 and obtained the best combination as this. Moving on to the research contribution is study the background of the price prediction of technical indicators, methodologies that are used in the stock market, identify the individual technical indicators and their strengths and weaknesses, come up with a critical analysis of how to combine those technical indicators, and finally introduce the best combination of the technical indicators to price prediction as the average of SMA, inner band, upper band, lower band, average price, and the EMA with the STD and CMF. Thank you. Lavanya,
Okay, since the author is missing, we won't be able to ask questions. We'll move to the next presenter. It's actually 3 presenters. The paper is titled Random Forest as a Novel Machine Learning Approach to Predict Land Size Susceptibility in Kalutara District. The authors, the first author, Oshani Sisira Veerakorn, has completed her BSc Honours Degree in Information Systems from the University of Colombo School of Computing in 2020. Her research interests include geographic information systems, data analytics, human-computer interaction, requirement engineering, and business information systems. The second author, Sachini Palyaguru, a graduate from University of Colombo School of Computing in Information Systems, and her research interests are in machine learning and data mining. The third author, Lasini Chamika Lienage, has earned her BSc Honours Degree in Information Systems from the University of Colombo School of Computing. And she has a BSc Honours Degree in Information Technology, specializing in software engineering from Sri Lanka Institute of Information Technology in 2019. She is currently working as a software engineer at WSO2, and her research interests are machine learning, data mining, and data science. Authors, the floor is over to you.
Hello everyone, I'm Oshani Veerakorn, presenting you with our research landslide susceptibility prediction model for Kalutara district. And the co-authors of this research are S.T. Palyaguru, L.C. Lienage, O.S. Veerakorn, and our research supervisor, Dr. G.D. S.P. Vimalaratnan. And we are from University of Colombo School of Computing. Taking an introduction to our research, a landslide is a phenomenon of a denudation process whereby soil, rock, or debris is displaced along the slope by mainly due to gravitational forces, as you can see in this video. And in Sri Lanka, an area of nearly 20,000 square kilometers that is covering 10 districts has been identified as prone to landslides. And there are 5 main categories of landslides. However, in Sri Lanka, the debris flows and the rock flows have been identified abundantly present in the Sri Lankan context. The causes of landslides are also different, and there are mainly 2 categories as terrain factors and triggering events. And terrain factors again get divided into 2 as natural and man-made. Stating our problem to solve in this research, we identified in Sri Lanka the number of deaths occurred due to landslides have been taking an increasing leap in the recent years. As you can see, in 2017, the number of total deaths have been just a little below than 250. In 2017 itself, 101 total deaths have been occurred in Kalutara district alone, while there have been 38 total landslides occurred in Sri Lanka. And here are some picture proofs to review how much destruction these landslides have been causing in terms of property, land, as well as human lives. And all these pictures are belonging to the destruction in Kalutara in the year of 2017. So we selected Karuthura district as our case study to predict landslide susceptibility in that area. So the Karuthura district is situated in western province Sri Lanka, and we initially identified that no earthquake-induced landslides have been occurred in this area, and all the landslides have been induced due to high-intensity rainfall. The NBRO, National Building Research Organization, currently builds landslide hazard zonation maps using a set of factors. These factors we called landslide conditioning factors, and they have been marked here as terrain factors. Slope, geology, hydrology, landform, soil type and thickness, and land use are these 6 factors. And MBRO uses rainfall as a triggering event only to issue early warnings to communities that live in the vulnerable places or the areas that have been identified as prone to landslides. In the literature review that we conducted, on the basis of finding out the research approaches done by focus groups and other research communities in landslide susceptibility mapping, we identified 4 main approaches: expert opinion based, physically based, statistics based, and machine learning approaches. And we saw an increasing amount of researches done in using machine learning approaches, and the prediction results that they have been giving out have been promising as well. All these listed examples in our taxonomy are Web of Science listed journals from the years 2013 to 2019. And in these 2 slides, you will be seeing some of the highlights of our research literature review, and we identified random forest as a machine learning algorithm has been a newcomer to this landslide prediction researchers, and it has been giving promising results with better prediction accuracy. And the research gap that we identified in here, after all this information we gathered up, there have been lack of studies that have been done on machine learning techniques using them than statistical approaches in Sri Lanka. And we also identified NBRO uses a 6-factor model only consisting of terrain factors and rainfall as a very important triggering factor. They are not using it for building the zonation maps. So the main research question that we drafted to continue our research is how to predict landslide susceptibility using a machine learning approach, employing the data extracted from contour maps, geospatial statistical data, and precipitation data. So under the main research question, we extracted 4 sub-research questions, and if I listed down them in summary, determining spatial relationship between the landslide conditioning factors and the occurrence, how to eliminate conditioning factors having low or null predictive capability, and identifying machine learning algorithms that are giving promising results, and evaluating proposed approach. The research design and methodology that we followed is summarized in this view. A better representation on each of these phases are contained in our later slides. So if I give a brief explanation here, we first build up our landslide inventory from the data sources that we obtained from NBRO, National Building Research Organization and Department of Meteorology. And then we selected out conditioning factors, 12 factors in total. And then we ran correlation analysis and feature selection using frequency ratio and information gain ratio, and selected out the best out of the 12 factors that are having higher prediction capability. And then on the training data set, we ran our random forest-based prediction model. And then we ran the prediction model that we obtained on our testing data, and finally evaluated our prediction accuracy of the model. The research methodology that we followed is hybrid approach of quantitative research approach and design science research approach. And we use QGIS 2.8, which is a GIS mapping tool. And the data sources that we used are contour data and geospatial data we received from National Building Research Organization, and precipitation data that we obtained from Department of Meteorology. And to prepare the landslide inventory map, we obtained 84 landslide locations in Kalathara, and these are the 12 factors of landslide conditioning factors that we initially gathered. Implementation of proof of concept of prototype. So here you can see the landslide inventory map that we built using QGIS by the contour data and geospatial statistical data we obtained from NBRO. And these blue dots represent the non-landslide 84 points, and red dots represents the 84 landslide points. And the digital elevation model, which you can see on the left of your screen, are the result of the landslide inventory map when we generated this from the QGIS. So using this DEM or digital elevation model map, we extracted slope, aspect, SPI, STI, and TW maps. In this cartographic model, you can see the steps that we followed to obtain these 5 thematic maps of the conditioning factors from the elevation map or the DEM map. And here are the results of our extraction: slope thematic map, aspect thematic map, SPI thematic map, TWI thematic map, and STI thematic map. And from the precipitation data that we obtained, we also generated the rainfall thematic map using QGIS. In this cartographic model, you will be able to see the steps that we followed to obtain or extract rest of the conditioning factor maps. So here are our results of the geology thematic map, hydrology thematic map, landform thematic map, land use thematic map, and soil type and thickness thematic map.
The spatial relationship or the correlation between landslide conditioning factors and the landslide occurrences were identified using frequency ratio. When frequency ratio is greater than 1, it suggests a strong relationship between the landslide event and conditioning factor. When frequency ratio equals 1, it suggests an average value. In order to remove conditioning factors with zero or null predictiveness, information gain ratio was used. This is because predictive capability of the model can be reduced by factors having certain noise level. To extract the features for each landslide and non-landslide point, raster and vector functions in QGIS were applied on the thematic maps obtained. Categorization of continuous values obtained for slope, aspect, SPI, TWI, STI, hydrology, and rainfall were carried out by dividing them into equal interval classes. This is the cartographic model which represents the steps followed in the feature extraction process. The landslide susceptibility prediction model was implemented using random forest as a machine learning algorithm. Random forest is an ensemble classifier which uses multiple decision trees to make the final prediction. Ensemble prediction from the forest of decision trees tend to be more accurate than a prediction from a single decision tree. RF uses two powerful concepts in machine learning called bagging and random feature selection. In bagging, each tree in the forest is trained using different sets of samples from the decision tree, and the final prediction is made by averaging the prediction of each decision tree. In random feature selection, there are two parts that needs to be highlighted. The first one, where a random set of features is selected to split the nodes in each tree, and the second one, where the conditioning factor which produces the most separation between the data in the left node and right node is used to split the nodes at each level. This reduces the correlation between any decision tree in the forest while maintaining the strength. There are several hyperparameters taken by RF classifier as inputs. In order to come up with a model with best prediction accuracy, the following hyperparameters were tuned. The optimal values for them were experimentally obtained by testing for different possible combinations of values. The table shown in this slide lists the set of hyperparameters used in their optimal values. Results and evaluation. The evaluation experiment was carried out in two phases where frequency ratio and information gain ratio values were evaluated to identify the correlation and to select the most suitable set of features for the model. And in the second phase, the performance of the model was evaluated using area under the ROC curve and accuracy, sensitivity, specificity, and kappa index values obtained using the confusion matrix. Using the frequency ratio values obtained for different classes of conditioning factors, it was evident that only some of the classes contribute to landslide occurrences in Kalutara district. As given in the table, areas with quartz of felsic geology are more susceptible to landslide, while areas with chronotite, chondrolite, and granite biotigenesis contribute the least to landslide occurrence. Similarly, the charts given in this slide shows the contribution of each class of a particular conditioning factor to landslide occurrence as a percentage. The classes highlighted in red demonstrated the highest probability of landslide occurrence in Kalutara district. While previous slide represented the values for raster data, this slide represents the same for vector data analyzed in the study. This table shows the information gain ratio values obtained for each conditioning factor. Since none of the factors shows zero information gain ratio value, all the 12 conditioning factors were utilized in the implementation of the model. Out of the 12 factors, geology, soil thickness, and SPI showed the maximum information gain ratio values. Finally, the evaluation of the implemented landslide susceptibility prediction model was carried out using area under the ROC curve. It obtained a value of 79.46%, demonstrating good predictive capability. The following accuracy, specificity, sensitivity, and kappa index values were obtained using confusion matrix. They also suggested a substantial reliability of the model. Using the results obtained from the RF-based prediction model, a landslide susceptibility map was implemented for the study area. In order to identify susceptible regions, landslide susceptibility indices were calculated and divided into 5 groups using natural breaks method. This map shows the high, moderate, and low susceptible areas of landslides in Kalutara district. Conclusion. Using this research, we were able to gather knowledge on applicability of 12 conditioning factors to predict landslide susceptibility in Kalutara. Comparative studies indicated that RF show better performance in landslide prediction. Frequency ratio values indicated that only certain classes of a conditioning factors contribute to landslide occurrence. Information gain ratio values indicated none of the factors had null predictive capability to landslide occurrence. The final model showed 80.39% accuracy, 79.46% area under the ROC curve value, 76.92 specificity, 84% sensitivity, 0.61 kappa index value. The future work of this study includes improving the accuracy of the current model by using other parameter fine-tuning methods, investigating the possibility of using other machine learning algorithms to get an improved model, then investigate the applicability of other landslide conditioning factors to predict the landslide susceptibility, and finally, applying this existing model to detect new landslides in other regions of Sri Lanka. That's it. Thank you.
Thank you, presenters, for that presentation. Audience, are there any questions? Okay, if there's no questions, let me ask one. When you're presenting, you alluded to the fact that there are other factors other than the 3 factors that you have presented. What motivated you to stick with those 3 factors instead of instead of moving with the other factors?
But can you explain the other three factors? Can you explain the question
I mean,
a bit?
no. When you were presenting, you said that there are other factors that you can look into in the future to predict landslide. However, you only looked at three sort of data types. I mean, what motivated you? Why did you pick those three?
Assuming that you are mentioning about the three data sources that we acquired, the geospatial, statistical data, contour data, and precipitation data.
Okay.
It is
I
true
mean,
that
can the presenters open the videos so that the audience see who they're
yes,
talking to? Okay.
So there are two types of factors for landslide susceptibility prediction. The first one are the triggering factors. The second one is the terrain factors. So basically there can be different terrain factors and triggering factors. For Sri Lanka specifically, the triggering factor is rainfall. So because we don't have like volcanoes and all.
and
Then earthquakes and the triggering factors we have the terrain factors we have considered 12. There can be others too. There are some factors like plan curvature, NDVI. There are some others too, but going through the literature we considered 12 factors.
Okay, so can you explain me how you combine those three data sources to come up with your predictions?
So basically we had to do different, we processed our maps using QGIS. So basically we prepared maps and got the values using those maps.
No, I mean, how did you, I mean, your decision behind, I mean, contour maps and rainfall data, what sort of mechanism, what sort of method you use to combine those two together to say, okay, this is how these two can be combined so that we can come up with, we can say there's a rainfall today, there's a rainfall next day, so that there will be a probability for a landslide.
So
the data that we collected was from NBRO. So those data are not real-time data; they are historic data. So
Okay.
We won't be able to make real-time predictions from this model. And talking about the nature of the data that we got, the National Building Research Organization provided us with this statistical data and contour data in terms of CSV files. So the QGIS tool that we used, it allows us to process these maps that we showed in the presentation as thematic maps. And in the similar way, we built the rainfall thematic map as well from the data that we got from the Department of Meteorology. So there are these functions in the QGIS as reclassification, interpolation, etc. that are used in geographical information systems scope. So we used those particular functions to build out our maps, and that is how we came up with these 12 conditioning factor maps.
Okay. Audience, are there any questions? Right. If there's no other questions, thank you presenters for presenting. I know it's difficult with this online environment and all. Hopefully, we will see you, at least some of you, next year in a physical ICTer conference. Until then, over to you, organizer.
Thank you very much.
Thank you, Dr. Tilna, for nicely conducting the session. So this marks the end of this session 3B, but our event has not ended yet. As you know, the final ceremony and the best paper award sessions are going to be carried out, and they will be carried out in our parallel session 5B after it ends. So because we are winding up early, those who have to go to the final ceremony and the awards presentations, you have to move to the session 5A. So with that, I would like to conclude this session, and thanks for everyone who helped us conduct this session well.